Good morning, students. In the last lecture, we had studied definition of hydrocarbon and classification of hydrocarbon. We know hydrocarbon means organic compound containing carbon and hydrogen elements only. Then we had studied this open chain hydrocarbons are classified into saturated and unsaturated, and example of saturated hydrocarbon is alkane. In this lecture we will study about alkanes in detail. So first point is the definition of alkane. So what are alkanes? How alkanes are defined? Alkanes are aliphatic saturated hydrocarbons containing carbon-carbon and carbon-hydrogen single bonds. So this is definition of alkane. Again, I will repeat the definition of alkane. Alkanes are aliphatic means open chain, saturated means containing single bond. So alkanes are aliphatic saturated hydrocarbons containing carbon-carbon and carbon-hydrogen single covalent bonds are called alkanes. The general formula of alkane is CnH2n plus 2, where in the general formula N is number of carbon atoms. Now the next point is why alkanes are called as a paraffins. The reason for alkanes are called as a paraffins because they are chemically less reactive due to they have no affinity with other chemicals and therefore they are less reactive. Already we had studied that alkanes contain carbon-carbon and carbon-hydrogen single covalent bonds, and they are chemically less reactive and they do not have any chemical activity, not too much activity, affinity for the other chemicals, and hence they are called as a paraffins. This is the reason why alkanes are called as a paraffins. So remember the general formula well for alkanes as CnH2n plus 2. After this definition and general formula, we will study about isomerism in alkanes. So what is isomerism? This isomerism means, very simple definition for isomerism is this organic compound having same molecular formula but different structural formulae are called isomers, and this phenomenon is known as isomerism. In chapter number 14, Basic Principles, we had studied in detail about isomerism and the types of isomerism. So the type of isomerism present in alkane is structural isomerism, that is also called as a chain isomerism. Structural isomerism or chain isomerism. The number of possible structural isomers increase with number of carbon atoms, and for this we will study how this number of isomers of alkanes will increase with number of carbon atoms. See here table number 15.1. It contains the first column as a number of carbon atoms. These are 1 to 6. Then example of alkane as a methane, ethane, propane, butane, pentane, hexane. These are the different examples of alkane with increasing carbon number. So depending upon this carbon number, see that If one carbon containing alkane, there is a no structural or no chain type of isomerism. Carbon 2 containing alkane, they do not contain the structural isomer. Similarly, carbon 3 containing alkane is a propane that do not contain structural isomer. In short, first three alkanes, they do not contain structural isomer. But from the carbon number 4 onwards containing alkane, that is a butane, pentane, hexane, they have 2, 3, and 5 isomers. So if 4 carbon containing alkane is a butane, then it contains the 2 isomers, and the names of these isomers are N-butane and isobutane. This pentane have 3 isomers, and these are N-pentane, isopentane, and neopentane. Then hexane have 5 isomers, that is N-hexane, isohexane. This iso have 3 more isomers, and this neohexane, it is 1 more isomer. In this way, there are 5 isomers. In short, so we will study all these isomers in detail in the next part of this chapter. And this butane, it is a 4 carbon containing alkane, contain only 2 isomers. Pentane contain 3, hexane contain 5 isomers. In short, this number of carbon atom increases, the number of isomers that also increases. Here we will study this isomers given for structural isomers of butane and pentane. See here, first compound, it is a butane containing carbon 1, 2, 3, and 4. Here each carbon is bonded with 4 bonds. So first carbon with 3 hydrogen, second carbon with 2 hydrogen, third carbon with 2 hydrogen, and fourth carbon with 3 hydrogen. Like this, it is a single bond containing 4 carbon containing alkane. Its name is a butane, and all carbon atoms in this compound are in a straight chain, hence called as a normal, and therefore in the name prefix N is given, meaning is normal. So N-butane means normal butane or straight chain butane. The second isomer of butane, we had studied in this table that butane contains 2 isomers. One of the isomer is N-butane, and the second isomer is isobutane, which contains 3 carbon atom in a straight chain, and fourth carbon atom is one branch. It is present on second carbon. So it is CH3, CH, CH3, and CH3. IUPAC name of this compound is a 2-methyl propane, or commonly called as a isobutane. Similarly, in this table we had studied that the butane pentane contains 3 isomers. It is a 5 carbon containing alkane, and these isomers are N-pentane, then isopentane, and neopentane. IUPAC names of these pentane isomers are given as pentane, 2-methylbutane, and 2,3-dimethyl-propane. So first is pentane, or common name is N-pentane. So it contains 5 carbon atoms in a straight chain, with each carbon is bonded with 4 bonds. So these valency are completed using hydrogen. So this first carbon is a CH3, second is CH2, 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 and finally CH3. This is structural isomer or structural formula of N-pentane. Second structural isomer of pentane is isopentane, and it is CH3, CH, CH3, CH2, CH3. Here, second carbon contains one side chain of one carbon, that is of methyl, and hence The common name is given as isopentane. Then one more isomer, structural isomer of pentane is neopentane, or IUPAC name is given as 2,2-dimethyl propane. Here, three carbon atoms are in a straight chain and two carbon atoms are branched. That is, on middle carbon, on central carbon, there is one branch above the chain and one branch below the chain. This is neopentane. So these are the three isomers of pentane. And that is about the structural isomers and isomerism in alkane. Thank you.